Hello friends, in this section we will cover derivatives of inverse function and also learn how to find derivatives of inverse function. So first of all we learn what is meant by inverse function. What is meant by inverse function? In previous class we have already learned what is meant by inverse function. Suppose I take f is a function from a to b, then its inverse function is denoted by f inverse. Then what will happen in f function from a to b and inverse function is denoted by f inverse, just is interchanging its domain and codomain. B to a. If f is a function from a to b, then its inverse function is denoted by f inverse from b to a. Suppose a set, here b set. We are taking x element, its image is y. Okay, so how it is denoted by? We get y is equal to f of x, which means that y is the image of x under function f, and it is denoted by y is equal to f of x. Okay, then how it is denoted by in inverse function? Then it is denoted by, suppose f inverse from b to a. In the b set, which element present? B set present y element, so here y as it is. In a set is x element, so here is a set, then x element. Then how will it is denoted by f inverse from? It is denoted by x is equal to f inverse of y. Why? Because x is the image of y under which function? F inverse. So we denoted by x is equal to f inverse of y, that is x is equal to f inverse of y. So this is inverse function. If y is equal to f of x be any function, then its inverse function is denoted by x is equal to f inverse of y. Okay, then we have to learn how to find what derivatives of inverse function. Before we learn how to find derivatives of inverse function, first of all we find regular derivative y with respect to x function. Suppose we take one example, y is equal to f of x form. Example, which form? Y in terms of x form. I will take one example in which form? Y in terms of x. Let y is equal to 2x minus 2. Then differentiate y with respect to x. Differentiate y with respect to x. Why y with respect to x? Here we differentiate y with respect to x. But why? Because our function is which form? Y is equal to f of x form. So its derivative dy upon dx is equal to derivative of d by dx of 2x minus 2 is equal to, then x derivative is 1 into 2 minus 2 derivative is 0 because 2 is constant function is equal to 2. Therefore we get dy upon dx means y with respect to x derivative is 2. Okay, this is our regular derivative y with respect to x form. Now how to find its inverse function? Inverse function means here we have to convert example, give one example in which form? x in terms of y, x in terms of y. So our example is y is equal to 2x minus 2. So you have to find x value in terms of y. Means this given function is called a inverse function whenever you find x in terms of y value. So x is equal to, we get y plus 2 upon 2 function. So here y is function which form? X form. Therefore you will differentiate y with respect to x, but here is a function x in terms of y. Therefore here you will differentiate x with respect to which function? Y. Here you will differentiate x with respect to y. Therefore dx by dy is equal to 1 upon 2 is constant, then d by dy of y plus 2 is equal to, whenever you differentiate d by dx of with respect to x, then its derivative is 1. Then here you differentiate with respect to y with respect to which function? Y. Then here is also derivative 1. 1 by 2 as it is. With respect to y, derivative is 1, then 2 is constant, 2 derivative 0, then your answer will come 1 by 2. Therefore we get derivative of x with respect to, which function? Y function. What will answer? 1 by 2. So here what you will observe that what is the relation between dy upon dx and dx upon dy. Yes, whenever you find y with respect to x derivative, your answer is 2, and whenever you find x with respect to y derivative, then its answer is 1 by 2. Can we write, whenever you find x derivative with respect to y is equal to 1 as it is, and what is the value of 2? What is the value of 2? Can we replace 2 is equal to dy upon dx? Yes. 2 replaced by dy upon dx. Therefore we get relation. If you want to find x derivative with respect to y, then just take the reciprocal of derivative of y with respect to x. You will get answer x with respect to y. Similarly, we can find what we find, derivative of y with respect to x. What? Reciprocal of x with respect to y. 1 upon derivative of x with respect to y. This is the relation between inverse function y with respect to x and x with respect to y. Okay, you will understand what is the relation between derivative of y with respect to x and x with respect to y. Okay, note this formula as next problem solving. Here one more condition is remaining. What? Denominator is not equal to 0 is required. Means the dy upon dx is not equal to 0 whenever you find x with respect to y, and whenever you find y with respect to x derivative, then dx upon dy is not equal to 0 is required. Then you can find y with respect to x, and similarly you can find x with respect to y. Here I will take only derivatives of inverse function statement part only. You have to prove this theorem as a homework. Theorem statement only. If y is equal to f of x is a differentiable function of x such that the inverse function x is equal to f inverse of y is also differentiable, then show that dx upon dy is equal to 1 upon dy upon dx, where dy upon dx is not equal to 0. Note this formula whenever you have to find x with respect to y derivative is equal to 1 upon dy upon dx. Now we have to find example on the derivatives of inverse function concept. Here I will take only example derivatives of the inverse function concept. So we will start example now. Exercise 1.2, question number 1. This type of question first time included in the board syllabus. Okay, question number 1. Find the derivatives of the function y is equal to f of x. Means we have to find derivative y with respect to x. Given function is which form? Y is equal to root of x. So we have to find y derivative with respect to which form? X form. By using which concept? Using the derivative of inverse function concept. Find the derivative of the function y is equal to f of x using the which concept? The derivative of inverse function. X is equal to f inverse of y. First example, y is equal to root x. So given example is which form? Y in terms of x, means y is equal to f of x form. So here you have to find by using inverse concept, using the derivative of inverse function concept. So how to solve? Let us see. Let y is equal to root x is a given form. So first you have to convert inverse function form. Therefore inverse function means given example is y is equal to root x, means y in terms of f of x. Then first you have to convert x in terms of f of y, means inverse function form. x की वैल्यू y के फॉर्म में निकालने की. ओके, सो squaring on both side, y square is equal to root x square is x, that is we get x is equal to y square. So here you will get x in terms of y function. Therefore differentiate x with respect to which function? Y function. Therefore dx by dy is equal to derivative of y, which function? Y square. So what is the derivative of y? Derivative of with respect to y, our question is y square. If we want to find derivative of x with respect to x square, and what will happen? Then 2x. Here we are finding derivative of y sorry, not dy with respect to y, but which function? Y square. Whenever you find x square derivative with respect to x, then its answer is 2x. Here you have to find y square derivative with respect to y, and your answer is 2y is equal to 2y. So here required answer is dx upon dy is equal to 2y. But now you have to find derivative. Which derivative? Find the derivative of the function y with respect to x form. By using which concept? Derivative of inverse function concept. So by using inverse function formula, what is? You have to find dy by dx by using which concept? Inverse function. 1 upon dx upon dy. What is dx upon dy? Dx upon dy is 2y. Okay, but what is the value of y? Y means our given function. What is y? Y value is y is equal to root x. So put here 1 upon 2 times y. What is y? Root x. Therefore we get dy upon dx is equal to 1 upon 2 times root x. Okay, this is the final answer. By using which concept? Here you can find derivative y with respect to x. Actually, you directly find derivative y with respect to root x. Then you will get dy by dx is equal to 1 upon 2 times root x. But here our question is find the derivative by using which concept? Inverse function concept. Therefore, we take this step dx upon dy. Sorry, here dy upon dx is equal to 1 upon dx upon dy. Then it's dx upon dy is 2y. And what is y? Y means root x. Therefore, this is our final answer. Then you can also solve one example as a homework. Find derivative y with respect to f of x form by using which concept? Derivative of inverse function. Take example y is equal to x square. Find its derivative by using derivatives of inverse function concept. Then question number 2, same exercise 1.2, but question number 2 form. What is number question 2? Find the derivatives of the inverse function. First example, y is equal to x square into e raised to x. Y is equal to x square into e raised to x. What you observe in question number 2? Here, if you want to find derivatives of inverse function concept, but given example is which form? Y is equal to f of x form. But here you cannot convert x in terms of y. So therefore, here first of all we differentiate dy by dx. Then after finding dy by dx, then you will use formula dx upon dy is equal to 1 upon dy by dx. Whenever you put dy by dx, then you will get required answer, derivatives of inverse function concept. So solution, let me consider first example, y is equal to x square into e raised to x. So we have to differentiate first y with respect to x. Differentiate with respect to x. Therefore, dy upon dx is equal to derivative of d by dx of x square into e raised to x. Here which form? U into v form. U into v form. What is derivative? U as it is, v derivative, v as it is, then use derivative. So x square as it is, derivatives of e raised to x, then e raised to x as it is, then derivatives of x square. So x square as it is, e raised to x derivative is e raised to x, then e raised to x as it is, then x square derivative is 2x. So in this function what will common? Here e raised to x common, x and x common. Okay, so we take x e raised to x term common. So remaining term, here x is remaining plus, and second term only 2 is remaining. Okay, so here we find, first we find dy upon dx, x e raised to x plus into bracket x plus 2. So dy upon dx is complete. But here how to find derivatives of inverse function? So now what is our rule? Derivatives of inverse function. Therefore we know that dx upon dy is equal to 1 upon dy upon dx. So what is our dy upon dx? Our dy upon dx is x e raised to x in bracket x plus 2, 1 upon x e raised to x in bracket x plus 2. This is our required answer. Then next example, take as a homework. You have to find derivatives of inverse function. Same above problem we solve already. First example, y is equal to x into cos x. Here you cannot convert x in terms of y, so use this formula dx upon dy is equal to 1 upon dy upon dx. And second example is y is equal to x into 7 raised to x. Then next question number 3, depends on derivatives of inverse function. Question number 3, find the derivatives of the inverse of the following function. You have to find derivatives of inverse function and also find their value at the points indicated against them. First example, y is equal to x raised to 5 plus 2x cube plus 3x at x is equal to 1. Our question is, first you have to find derivative of the inverse function. Then means first you have to find derivatives of inverse function by using our regular concept, a previous above problem, and also find their value at the points indicated against them. Means at x value you have to find what its derivative. Okay, let us start example first. Its solution, consider y is equal to x5 plus 2x cube plus 3x given. Therefore we differentiate with respect to x. Therefore dy upon dx is equal to derivatives of x5 x raised to 5 plus 2x cube plus 3x is equal to, here three functions derivatives form u plus v plus w. You have to differentiate each term with respect to x. So first derivative is 5x4 x raised to 4 plus 3 to the 6 x square, then 3x derivative, 3 is constant but x derivative is 1. So you get here dy upon dx. Now by using inverse function formula, dx upon dy is equal to 1 upon dy by dx. What is dy by dx? Here already find it, is equal to 1 upon dy upon dx value is 5x4 plus 6x square plus 3 is equal to okay, this is required our answer. What is dx upon dy is equal to 1 upon 5x raised to 4 plus 6x square plus 3. Then okay, this is only derivatives of inverse function part. Then next part is you have to find their value, derivatives value at which points indicated against them. Means you have to find its value, derivatives value at which point x is equal to 1 value. So we have to find derivatives value dx upon dy at which point at x is equal to 1 is equal to where x is present, just put out x value 1, then 5 as it is, then 1 4th power, and 6 into 1 square, then 3 upon 5, 1 power is 1, then 6 plus 3, then 1 upon 14 is the required answer at which point, at which point x is equal to 1 point. This is the required answer. Then take next example as a homework. So find its derivative, y is equal to e raised to x plus 3x plus 2 at which point x is equal to 0 point. Okay, these question number 1 and question 2 and question 3 and question 4 also, these are 4 examples, just depends on derivatives of inverse function concept. You can also try as a homework exercise. Therefore, so first concept is clear. Which concept is clear? So first part is complete derivatives of inverse function. Next part we will discuss